Hello. In this video, we're going to start looking at the natural exponential function y equals e to the x power. But to understand that, we have to understand e. Now, there is an e on the calculator right here for division, and there's one over here for ln. But they're both, you have to use the second button up here to do that. So first, I'm going to click on second division, and you see it just says e there. E is actually just a number. It's weird, it's just a number. And if you do e, type it in, it's going to give you 2.718281828. But here's the thing. This e is very similar to pi. So if I type in pi and click enter, it gives me 3.141592654. Pi is irrational, which means that it's a decimal that never stops and never repeats itself, or there's no pattern that you can find to get all other decimals. So e here is pretty much the same thing, it's just a different number. It's 2.718281828. Now the question is where does this come from? Well, it actually comes from this formula, 1 plus 1 over x, all to the x power. Now this is not an exponential function, but it is interesting. So notice if I graph this, that going to the right, it's going up to some number, and it's going to approach this 2.718281828 as x gets really large. I think you have to get to something like 1 trillion before it gets to this decimal being an 8 there. But it will approach this. Now, if you want a bit more thorough of an examination of what e is, ask me and I will give you a video that I've made. Now, if I want to do e to some power, I can do that. I can do second division and the caret and then whatever we have there. E to the 6th power would be 403 point blah, 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 blah. But over here for the e to the x power, that's actually the best for typing stuff in like this. So if you do second ln, notice that it just says e to some power already. It's the same thing. It's just a, one less button to click. And it's actually going to be quite nice. In the next section, we're going to start working with logarithms, I believe. In the next section? Yeah, I think so. And you will be using these buttons, so don't think that you will escape being able to use these. Now, the reason that I've talked about this is because we want to graph e to the x power. So second ln, which is e to the power, so e to the power of x, and if I graph that, oh look, it just looks like an exponential function. Alrighty, I'm going to go ahead and go back to the notes and write down what we need there. I'll see you there. Okay, so welcome back to the notes. So looking at the natural exponential function, y equals e to the x power, this e is again approximately 2.718281828. And it just keeps going there. Now, while it does 18281828, the very next number is not going to be 1828. It's not going to repeat it again. So just, don't think that just repeats 1828 the entire time. But think of e as approximately 2.7. That's a good thing to think of. Now, notice that e is greater than 1. And so that means that whenever you graph the function, which is what you saw, it's actually an increasing exponential function because it's a number greater than 1. So the graph of y equals e to the x power is given, and we want to sketch the asymptote of the graph and label with the equation. So notice that the asymptote is just the x-axis again. In other words, y equals 0. Also label the 3 key points as ordered pairs and state the domain and range in interval notation. So to do that, the 3 key points, let's just use an xy table. The 3 key points are not going to change, at least for the beginning. -1, 0, 1 with a 1 right there. The y here, because this is a negative, we're going to take the reciprocal of the base, and the base is e. So the reciprocal of e is just 1 over e. Now for the blank here, this 1 means we keep the base, which is e, so it's just e. And so there you go. Those are the ordered pairs. Now, as for the domain and range, the domain will not change. It is still negative infinity to infinity. And the range, well, it's 0 to infinity, just like what you would expect with an increasing exponential function in its parent form. Fantastic. Now, I do recommend that you graph y equals 2 to the x and e to the x on your calculator. Look at the differences between those two. And the natural exponential function can be used to model phenomena such as radioactive decay, population growth, and continuous interest investments. Now, if it's continuous, if you have compound interest that is continuous, so called continuous compounding, the formula changes from a equals p, so a equals p times 1 plus r over n to the n times t. This changes to the new formula of a equals p e to the rt. So we don't actually use that formula anymore if it is continuous compounding. So it's actually very important that we understand anytime you see that word continuous, we actually mean this formula. Alrighty. Well, I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.